We're going to put everything together today. We're going to graph these sine and cosine functions, and we're going to combine the phase shifts, vertical translations all together. We found out what the amplitude, this k value does, and the c value does, as well as the d value, all isolated cases. Maybe we've combined two, but today we're going to combine sometimes 2, 3, and 4 of these things all at the same time. All right, so let's go ahead and get started. First, we'll graph the y equals sine of 3 theta minus 60 degrees. We'll start in degrees and work to radians just because you're more familiar with degrees. So the first thing we've got to see is this is not in the proper form. We have this 3 paired with the theta, and we need to get theta isolated by itself. So we're going to take and factor by pulling out a 3. That gets us theta minus 20 degrees. And then we're going to take and identify what all this stuff means. Okay, I got an amplitude of 1. Now my period is going to equal 360 or 2 pi, however you want to look at it, over the k value, which is 3 or 120 degrees. Now, that sets up intervals being 120 divided by 4, or at 30 degrees. I know I have a phase shift, or a or a horizontal translation, sorry about that, of 20 degrees to the right. So now I'm going to just go ahead and graph all this. I'm going to start at 20 degrees, and I'm going to move in intervals of 30 degrees to my right. So I've got 50, 80, 110, and 140. From 20 to 140, I have a total of 120 degrees, and that's going to be my period. I know my amplitude is 1, so I'm going to go up 1 and down to -1, and I'm going to graph a regular sine function. So in graphing that regular sine function, we just take and start at 0, move up to 1, back to 0, down to -1, and back up. And if you really wanted to, you could check an actual value. Let's just go ahead and check a value for 110. So if I have 110, that's sine of 3 times 110 minus 20. We know 110 minus 20 is 90, so that's 270. And the sine of 270 degrees is -1. It checks out. So everything's all good. All right, let's move to our next example. Similar situation, except we've got a cosine function. We're going to take and factor out once again that 2. So I've got the cosine of 2 times x plus 50. I've got an amplitude of 1 again. I've got a period of 360 over 2, or 180. I have intervals equal to 180 over 4, which is going to be 45 degrees. And I have a phase shift of 50 degrees, this time going left. So once again, set up axis starting at 50 degrees of the negative type, and I'm going to add 45 degrees to that. Puts me at -5, positive 40, 95, and add 45 to that, 140. And once again, you look, and I should be at a total of 180, which I'm not, so I added wrong. What do you know? Shocking. So it should be 1 This last one's a whack job. Ah, here we go. 45 is 85. And then, so it's 130. Sorry about that, fellas. So then we take and graph cosine. Again, my amplitude is 1, so I'm going to go from 1 to -1. Start up, go down, down to -1, up, up. And there's our cosine function. And again, if you wanted to plug in a point to check, knock yourself out. All right, next. So now we're going to work in terms of pi's. Again, we have to take and factor. So I have y is equal to the cosine of, I'm going to pull out a pi over 2, and left with theta minus 1. So now amplitude, once again, is 1, period, equals 2 pi over my k value, and k is pi over 2. So that's just 4. I have intervals equal to 4 divided by 4, which is equal to 1. And I have a phase shift of 1 to the right. And we'll go ahead and start graphing this on our axis. Hopefully we do a better job than I did last time. So I'm going to start at 1 in the positive direction. I'm going to add 1 to that every time. 2, 3, 4, and 5. That should get me 1 period, because that's a total of 4 between the two. And then I'm going to take and look at my amplitude, which is 1 in both cases. 1 here, -1 there. And I'm going to take and graph a regular cosine function. So regular cosine function starts at 1, down, down, up, up. And let's just go ahead and check this for kicks. All right. We'll take and use this point here. We'll plug it in. So I have the cosine of pi over 2 times 3 minus 1. 3 minus 1 is 2, and pi over 2 times 2 is pi. We want to know the cosine of pi, which is equal to -1. Sure enough, there it is. So we check. Next example. Let's do it again, except this time we've got everything going on. We've got up and down, we've got amplitude change, we've got phase shift, and we've got period changes. So we'll take, once again, factor out, pull out a pi, leaves me with theta plus 1/3 plus 1. All right, so in this case, we've got an amplitude, 4, period, which is equal to 2 pi over pi, or 2. We've got a interval equal to a half, because that's 2 divided by 4. We've got a phase shift of 1/3, moving to the left. And now we've got a vertical translation of 1. So that's going to move that midline. All right, so we'll go through and do all this now. I'm going to start at -1/3. Right, and I'm going to add halves to that. So while I'm doing this, I might as well change this to sixths. So 1/3 into sixth is -2/6. And I'm going to be taking and adding 3/6 to that throughout. So if I add 3/6 and -2/6, I get 1/6, then 4/6, then 7/6, and finally 10/6. And if I look from 10/6 to negative 2 sixths, that's negative 12 sixths, or 2. So I've got all my intervals done correctly. Now I'm going to take and change my midline. I'll move my midline up to 1. So here's my midline. Hopefully you can see that in yellow. All right. And then what I'll do from that midline is I'll graph up and down 4. So let's do that. We'll go up 4 from here. That puts me at 5. And down 4 from here puts me at negative 3. And so I'm going to graph a regular sine function from this midline and the negative 1/3. So I usually start at my 0, and my new 0 is my midline. I go up the amplitude, back down to the midline, down to the minimum, or down the amplitude, and then back up to the midline. So once again, I'm here. I'm going to check a point just for kicks. Let's check the point. Let's check 4/6. All right. So 4/6, which is 2/3, I have 4 sine. So once again, we're checking this point. 4 sine of pi times 2/3 plus 1/3 plus 1. So this is 4 sine of pi plus 1. We know that the sine of pi is 0 plus 1 is 1. And look where this value is. It's at 1. So this checks out. All right, next example. Couple more. All right. So next, we're going to take and do very similar to this problem here. Factor out negative 2 times the cosine. We're going to pull out 1/4 pi. The trick's going to be what? 1/4 times what is negative 3/2. All right. So I've got to take and think about what's going to do that for me. And if I go 6 pi, I think that'll get the job done. Actually, just 6. That'll get the job done because that's 3/2 when I reduce. And there's the pi minus 4. So I've got amplitude of 2, but since it's negative, it's going to take the cosine and turn it upside down like this. All right. I have a period equal to 2 pi over pi over 4, or 8. I have a phase shift of 6 moving to the right. I have intervals of 8 over 2, or I'm sorry, 8 over 4, which is equal to 2. And then I have a vertical translation of 4 down. All right, so let's go ahead and start plotting all that. And we start at a 6 and moving in intervals of 2 going up. 8, 10, 12, 14. There's my period. I'm going to drop my midline, a total of 4. So if that's 0 and I drop my midline 4, I'm going to go down to negative 4, put that midline right around here. My amplitude's going to be 2 up and down from that, so I'll go to negative 2 and negative 6. And then I'm just going to take and graph a regular cosine graph. So I go up my amplitude, but instead of starting up high, I'll go down because of that negative in front of the 2. So I start down, move back to my midline, up, back to my midline, down. And there we have it. All right, so no more graphing. Now we're going to take and actually write an equation of a sine function having the following properties: amplitude, period, phase shift, and a vertical translation. So I know if I have an amplitude of 7, that goes out in front. So that's 7 times the sine. Now I want a period of 3 pi. So normally my period for sine is 2 pi over the k value. I need to find the k value. So k in this case is equal to 2 pi over 3 pi, or 2/3. So I'll put that 2/3 right here. I like putting it in factored form. And then put my theta right here. I have a phase shift of pi over 3 to the left, so that means I'm adding, and I'll just put pi over 3 right here. That's the beauty of taking it and putting it in factored form. You can just throw your phase shift right into that value there. And then I'm going to have a 4 up translation, so pop that on the outside. Set that all equal to y, and I'm out. All right. Last example of the day. This is the tough one. We're going to take and actually write the equation of this. We're going to call this a cosine function. So I know this is a cosine, which means I should look from peak to peak, but unfortunately in the graph that I've given you guys, I don't really have the two high peaks. I only have this high peak here. But in order to find a period of anything, all I need to do is go from where it repeats. So I look and I notice, all right, well, this repeats right, or starts here, and then repeats over here. And if I follow these lines up, this puts me at -70. And this puts me at 110. So if I'm moving from -70 to 110 in total, I have a total of 180 degrees. And that's my period. Now, if I cut this thing dead in half with a midline, my midline appears to be going across in this fashion. All right. So I look at how much I've traveled from that midline. If this is -4, and I move up to -3 and down to -5, that's really only going up 1 and down 1. So my amplitude hasn't changed. Now cosine usually starts up. So this is where my cosine usually starts. So it appears that I've moved over 20 degrees, which is my phase shift. All right, and now I'm going to piece together this graph. So I know my period is 180. So if my period is 180, I'll do it right here. Period is equal to 180 is equal to normally 360 over k. So k ends up equaling 2. So now I have a y equals. We said my amplitude's the same, so it's just a regular cosine because the amplitude's 1. K is equal to 2. Theta, we said my phase shift was 20 to the right, so it's -20 degrees. And my midline has moved down 4. And there we have it. Okay, hopefully that was good enough to get you a start on tonight's homework. Take care. Hopefully see you Monday.